So we see experiment 5 based on multi-layer using PyTorch. So in this we imported library torch. So torch is a Python library function. So torch it is the deep learning framework we will use to build and train our neural network. So in this torch.nn, this gives us the building blocks of neural network like layers and activation function. So torch.optim, this provide optimization algorithm like Adam, which we will use to update the weight during training. So next we will see read the dataset from SQL and library. So it is load the dataset from skitlearn. So in this load, it gives the undersub data values. Each image represents from 0 to 9. So next one, choose independent variable x and different variable y from the dataset. So this cell is explicitly confirmation assign our independent variable and dependent variable. So it is referred to the independent variable. Well, these are future our model will use to learn. Here the X contains 64 pixels. 64 pixel values of each image. These are input to a neural network. Y is the dependent variable. So this is what our model is trying to predict. Here y which is label 0, 1 to up to 9. Dependent variable also called features or input. Dependent variable is also called the target or label or output. The shape remains same as before. 1797 rows and 64 column. It refers the this is refer as the row and 64 refers as the column for X. 17 and this Y 1797 refers to as label base. So next we see standardize the input variable using standard scaler. So now we standardize the input features using standard scaler from Skylab. When we have input feature with different scale, the neural network may struggle to learn efficiency. For example, one feature might have value between 0 and 16, which is the pixel range in the dataset, while another might range from 0 to 1000. This imbalance can slow down training or cause the model to coverage poorly. Uh, so in this, next split the data into training and testing value. The reason we split the data is very important. We want to train our model on the one portion of the data and then we test it on unseen data to check how well it generalizes. So we see test size 0.2, that means 20% of the data goes for testing and the remain 80% go for training. So this is the meaning of training and testing. We have split the data. So let's to convert the input to the PyTorch tensors. So PyTorch works with the own data structure called tensors, which is similar to NumPy array but with extra capabilities like being able to run on a GPU and supporting automatic differentiation for back propagation. So in this H-train and X-trains are converted with D-type touch because the input features are decimal numbers, so we use 32-bit floating point. Y-train Y-test are converted with D-type touch dot long because the labels are integer class indice and 0 through 9. Uh, PyTorch across enterprise losses function specifically requires label to be type long. So next we will see define the MLP model layers configuration with this attribution at function. So this is the where we define our multi-layer perception model using PyTorch. We create class called MLP that inherits from the NL dot module, the base class for all neural network in PyTorch. Inside the intent method, we define the architecture using on sequential, which means the layer are stacked on after another in sequences. Um, let's look at the layers. Linear, um, 64 to 128. Uh, this the first layer takes 64 our 64 pixel features and product 128 output. This is a fully connected layer, also called dense layer. So RELU means standard for Recurrent linear unit. It is artificial function that introduce non-linearity. It simples output 0 for negative values and keep positive as is. Without artificial function, the network could just be doing linear math and couldn't learn complex pattern. So in this linear 128 64 second hidden layer reducing from 128 to 64 neuron. So in this linear 3216 means fourth ion layer. So RELU activation function and next is linear 1610. The output layer is 10 neurons have 10 neurons, one for each digit class from 0 to 9. There is no artificial function here because cause entropy loss, which we will use next, internally apply softmax for us. Uh, so next, training the model by updating the weight using back propagation gradient descent. So this is the training loop where our model actually learn from the data sets. In this we use criterion. This is our loss function. This measure how wrong the model predictions are for multi-classes classification. Cross entropy loss is the standard choice. Lower loss means the model is doing better. So optimize we see optimization. Uh, it adjusts the weight to reduce the loss. It is a learning rate which control how big data each object step is involved. Uh, so next, plotting the training curve. In this, well, we are plotting the training curve. The x-axis represent the number of iteration on n curve, and y-axis represent training error, which the losses value at each uh, values. Uh, so next, test the model. Uh, if if we use torch node grade, this is way during testing we don't need to calculate gradient because we are not updating any weights. Disabling gradient computation save memory and speed. In this we use prediction model. We do forward post array test data. This model output raw score for each of the 10 digit classes for every test sample. In this we see torch.max. This finds the maximum value along dimension 1. It returns two things. Maximum value is the index of the maximum values, and this index is the predicted label. Um, exporting result for tab.